What is Archimedes' principle?
Archimedes' principle states that the buoyancy force acting on a body submerged in a liquid is equivalent of the weight of the liquid displaced. The buoyancy force is equivalent to rho GV, where it will increase, which means it's directly proportional to the density, gravitational force, or the volume of the object.
Firstly, we measure the weight of the solid ball and measure the diameter of the ball using a vernier caliper. By using volume of a sphere formula, we can determine the volume of the ball.
With the following information, we concluded the density of the ball.
As shown, the ball has sunk to the bottom of the measuring cup as the ball is denser than the water.
136 grams of salt was then added into the water to test if the ball was able to float.
It is observed that the ball is floating midway inside the solution.
We added another 51 grams of salt to see if the ball will be able to float above the water. In conclusion, the density of water increases whenever salt is added. We can also conclude that there is also an increase in buoyancy as the ball will float closer to the surface whenever salt is added.
Now let's talk about what is Bernoulli's principle. The principle states that as the speed of the moving fluid, liquid or gas increase, the pressure within the fluid will decrease. The principle can also be expressed as a change in energy.
Go.
When the wind is blown between the balloon through the straw, there will be an increase in the velocity of air, followed by a decrease in the pressure. The atmospheric pressure surrounding them will be much greater than the atmospheric pressure between the balloons, hence drawing them towards each other. In conclusion, the ball was able to float in the air was because the velocity of air created by the hairdryer is greater than the surrounding air, resulting in difference in air pressure from the surrounding air, allowing the ball to stay within the column of air created by the hairdryer, as the pressure of surrounding air is much greater than the column of air from the hairdryer.